On the last lesson, you were really practicing hard on finding which part of the y equals mx plus b, which part was the slope, and where was the y-intercept, and how do I graph that? So today you're going to be taking tables and graphs, and you're going to actually be able to write equations based on the tables and graphs that you see. So we're going to be going the other way around. Instead of taking the equation and then making the graph, you're going to take the table or the graph, and you're going to be writing the equation based on that information. And so that's what we're on right now. And this is lesson 6-5. Lesson 6-5. So you should be putting this on page 62 and gluing it in when we're done. And hopefully you're gluing as we go. I don't let the video keep running for wasted time. So make sure you're opening up to those pages and actually physically gluing them on so that you get them taken care of. Okay, so we're going to be writing equations from tables and graphs. And so if you take a look at the black box here, linear equations can be written from tables and graphs. But first, there are some steps. Number one, determine what the constant rate of change or the slope is. So we're going to be finding our m value. So this is really, really important. That's probably the first step. Second step is, where does it hit the y-intercept, or where is the y value? And in this case, when x is 0, what is my b value? And then once you've done that, you just plug it into m right here for m and b for b, and you have your equation of a line. And it's that simple. So let's take a look at the first example here. So we look for the rate of change. So when we have a table, we do our change in y over our change in x. And that should be kind of becoming like very, very fluid with you. You should know it really well. My change in y, if you notice, there's an increase of 6 each time. And on my x, there's an increase by 2. So that means that the change is 6 over 2 or 3 over 1. And again, always make sure you have this in smallest form, in simplified. So my slope here, or m, is 3, or 3 over 1. And again, when we write our equation, we're just going to use 3, not 3 over 1, because that looks silly. And it's not simplified all the way. The second step, step 2, is determine the y-intercept. When x is 0, what is y? And so in this table, they were really nice, and they showed you exactly what the x is when the y, or what the y is when the x value is 0. And so when that happens, my y-intercept is 4. That means that my 0, 4, or b equals 4 is part of my equation. So very simply put, I plug everything back in. So I say, okay, what do I need? I need slope and I need b, and that's all I need because that's what you learned in the lesson yesterday. So it'd be y equals 3 is my slope, x plus 4. And there's your equation of the line. Very simple. Let's take a look at the next example. We have a graph. Now, I'm not looking at the writing part over here. You can, but I'm just going to talk you through it. Here's my graph. So the two things I need is slope and y-intercept. With those two pieces of information, I can get my y equals mx plus b by simply plugging in the m and the b into the equation. So let's start with y-intercept, because usually that's the easiest. I like to start there, is where is it hitting the y line? And if you notice, there's going to be a point right down here, and they didn't draw it for you, where it hits the y-axis. And this is located at the point or the ordered pair 0, 1, 2, 3, 4. So it's at -4. You don't need to put the ordered pair 0, -4. And the reason why is because the only part of the equation that requires it is where it actually hits with the b on the y-axis. So this is my b right here. So this will be -4. And I'm not going to put plus a -4. It's much better just to say -4, which means the same thing. So now to find the slope, I got to find some other points. So this is when you actually physically have to go in and put the points where the two lines are crossing over, and then count your slope. So you put your pencil or pen on there and you say, okay, I'm going to rise 1, 2, and I'm going to run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. That means my slope is 2 over 1, which is simply 2. And that is not a negative slope, but is actually a positive slope. The other way to do this, if you wanted to, is to pick 2 points and subtract your x and y's. So that's another way to think about it. So I want to show that to you. So we know that we had the point 0 and -4 right here. And then this point right here next to it is 1, -2. And so what you can actually do is subtract your y's, subtract your x's. So you can take these two, subtract those two, subtract these two, and do your change in y over change in x. So my change means subtraction. So I have -2 minus a -4, which is keep, change, which if the signs are different, I subtract and I get 2. And then on the bottom, we have 1 minus 0, which is just 1. And we know the slope's the same. I find it easier just to count rise over run. A lot of you are having issues with adding and subtracting integers, and this is causing problems for you. So you can kind of avoid it by just counting your slope yourself. So now we need the equation of the line. So it'd be y equals, the slope here was 2. So I plug in 2x. That's my changer. And then plus or minus. And in this case, it's -4. I almost put plus, but that b is a -4. So my equation is y equals 2x minus 4. Noticing on the notes over here, I put 2x plus a -4. Star will never do plus a negative like that. It'll always be 2x minus 4, which is a proper format for that problem. All right, let's go down here. We're going to do a few more examples together. Write the equations of the lines represented by the tables and graph. And we have 2 tables here and 1 graph we're going to practice with. So the 2 things we need are slope and we need our b. And these are kind of fun once you get the hang of it. So I'm looking for the change in y over the change in x, and I also need to find where it hits the y-intercept is when x is 0. So I look on my table and I say, oh, look, x is 0. This is my y-intercept, so b is 9. So you have the back end of the equation already, and that's good. And I know it's a positive 9 there, so I can pretty much on my equation write y equals something times x plus 9, and we have to find that slope right there. So I'm going to look at my y. I'm going to say, okay, is it steadily increasing on the x's? Yes, and if you notice, it's increasing by 5. So I'm going to put plus 5 over here. It's increasing by 5 steadily. On the y values, I'm jumping. You might not know how much of a jump this is, but from 9 to 29 is a jump of 20. 29 to 49 is a jump of 20. So I'm adding 20 on the y value, and I'm adding 5 on the x. So change in y is 20 over change in x is 5. 20 divided by 5 is 4. And I could have put 4 over 1, but again, that reduces to 4, and that's my slope. So it goes in front of my x, 4x plus 9, and I'm done. Don't make these hard, they're not, okay? So change in y's, change in x, and I'm going to look at the relationship. And remember, it's y over x every time when I'm doing my delta change for slope. So this is a positive 2, it's increasing. And I see that this is decreasing. A loss of 6, a loss of 6, a loss of 6, each time losing 6. That means that my slope is -6, y over the 2 is x, and this reduces to -3. So 2 times -3 is -6. That's reducing. So that's my slope. And then I want to find my y-intercept. It's already given. Now, if your y-intercept for some reason is not given in your table, always continue the pattern until you can find it. That's the easiest way to do that. So my b here is -7. So I'm going to put it in my equation. So y equals, my slope is -3, so -3x. My b value is -7, so it's -7, and I am done. So those are 2 equations of the lines for those 2 examples. Number 3 is a graph. Again, I want to find the equation of the line y equals mx plus b. I always like to start with my b. Where does it hit the y line? It hits it right here at the point 0, 1. That means my b, or my back number, is 1. So that's going to go back here, and it's going to be plus 1 because it's a positive, not a negative in the y-axis. Slope is change in y over change in x. It's my rise over run. So I know this is a negative slope. I'm going to go ahead and put it. And just a reminder, if you forget, you draw your slope guy up here and then just say, oh, it's going this direction. I know it's negative. I'm leaning towards this way. The one example up here was positive, so I knew it was a positive slope. So the steepness of this line is not as, it's not too great. So let's see what the slope is. So I'm going from here and then it crosses here and it crosses right where that point is pointing on the arrow and then up here. So let's make sure it's got the same rate of change. So I'm going to count down 1, 2, 3 over 1, 1, 2, 3 over 1, down 1, 2, 3 over 1. So I'm going a slope of negative 3 over 1, which is just negative 3. So that'd be negative 3x plus 1, and there's my equation of the line. I surely hope you have fun with these because they are a lot of fun. We're going to do a few more notes. I know that today might be a little lengthy, but I want to make sure you've got it. So I'm going to kind of travel through these kind of quickly. So some more notes. Let's just see if you're catching on. Write the equation of the line that is represented by the table. So I'm going to go kind of quick. So x is increasing by 2 plus 2. Y is decreasing by 2. That's a negative 2. So my m, my slope, is a change in y, negative 2, over a change in x is positive 2. This would be a negative 1. And if you notice, the graph is going to skip. I could put 1 and 3 in here and just set them in between. And that's okay to do. Then this would be 10, 8. This is actually 7, 6, 5, 4. So actually, as x increases by 1, y is decreasing by 1. And that's why the slope is negative 1. And again, we need this for our b. So our b here is 8. And I write into my equation here, y equals, and it's right here, my slope is negative 1. So I put negative x, and I'm not putting a 1 there because it's understood to be there, plus 8, and there's my equation of my line. Over to number 2. You have to look really carefully just to be careful. It's going steadily increasing by 1 on the x-axis, which is fantastic. So we'll put plus 1 here. And then I'm looking on the y-axis. Get a little tricky here. If you're having a hard time with the negative, just start with the positive. You don't have to start back here. So 1 plus 2.5 would make 3.5. 3.5 plus 2.5. So a half and a half make a whole, and 3 and 2 is 5, and the whole makes 6. So we're adding 2.5 each time. So my slope here is 2.5. My b is, where does it hit the y-intercept? It's 2.5 over 1, by the way, guys. So that's just 2.5. And my y-intercept is when x is 0. That's 1. So y equals 2.5x plus 1. And there's the equation of my line. Going over here to the second example or third example on my graphs, 2 examples on tables, 2 on graphs. Write an equation in slope intercept form. Y equals mx plus b. So we're looking for our m, we're looking for our b. So our slope, we're going to look for the b first and then our slope, and it's where it hits the y line, which happens to be at the point 0, 2. So b is 2. My slope is going from point to point where the lines are intersecting. Draw those points in. It looks like a negative slope to me, so I'm gonna put negative because I can think about slope guy. It's gonna go down 2 over 1, down 2 over 1, down 2 over 1, so that's a negative 2 slope. And I'm gonna write my equation, negative 2x plus 2, and I'm done. Just find the m and the b. Let's take a look at this line. It's hitting the y line right here, so I can find my b. My b is at 0, negative 2, so b is negative 2. Looking for my slope, my change in y over my change in x. Very, very flat slope. When you see something like this, you definitely know that it's going to be a fractional part. It doesn't hit the crossing of the lines till here or here. Very flat slope. We're going to rise 1, run 1, 2, 3, 4, 5. So it's 1 over 5. Let's go the other way. Down 1 and left 1, 2, 3, 4, 5. So it'd be a negative over a negative, which is a positive. So the slope here is 1/5 x minus 2. And the reason it's minus 2 is because that b is a negative 2. Some real world problems. Juan has already earned $200. that's his start amount. So when they say he's already earned it, that's where he's going to start on his graph. And then it continues to say he continues to earn more money each day at a rate of $80 per day. Okay, my sheet didn't pick up the information over here too well, so I'm just kind of darkening this in for you guys. And so we're taking a look at Juan's earning. It says he's already earned 200, so 200 is where he's beginning. So that's here. So he's here. He's already started there. So that's his start amount at day 0. He's got 200 in his account. He earns more money each day at a rate of $80 a day. So he's earning $80 on the 200. That puts him at 280. So this is going to be approximations here. It's going to be a little bit of a graph with some difficulties because you're jumping from 200 to 300. So it says graph the relationship, and we're going to continue to do that. But I'm going to make a table really quick, and I'm just going to put days. And remember, time is always your X, and then Y is your dollar amount that he's saving. And so on day number 1, actually should put day 0. He has $200. And then on day 1, he has 280. So from here, he's growing. And this is not a proportional relationship because it doesn't start at 0, 0. So on day 2, we have another 80. So you add 80 to that to get 360. And here's where you got to do some math. And then on day 3, we're going to add 80 to that. It'd be 440. Day 4, we're going to add 80 to that. 520. And just continue to do a little bit of math there. Okay, so far, that's probably going to get me far enough right now. I'm going to go over here to 200, 280. Then it says 360, that's a little over half, which is 350. And then 440 is going to be a little under half. I just want this to look like a general trend upward. And of course, you can't go backwards into negative days, so this is about all you can graph. What is the slope and the y-intercept of the line? Okay, so the slope is basically what he rose and what you rise and what you run. So there's a change of $80. So we know that each time we have a plus $80 over one day. And so that's your change in y over your change in x. So my m is going to be, whoops, sorry, I didn't mean to put that, is going to be 80, because that's what we're changing each time. And our b or our y-intercept is going to be where 0 hits the y line. And so that's at 200. Write an equation to represent this for earnings for y for x days. So x is the changer. The number of days I'm getting $80 more a day, and that's what's changing. So that's 80x, and then plus the 200, because the 200 is what I already have in the account. So it's changing $80 a day with a start amount of 200. This is the initial start amount. If Juan earns money for 5 days, what is the total amount of money he will have earned? And notice we didn't finish the table, and we could have, or we can just plug into the equation 80 times 5, because the X is for days. And then we have to make sure we include the $200 initial fee. So 80 times 5, 8 times 5 is 40 with a 0 behind it. So we'd be at 5 days. So we'll be at 400. And then plus the 200. And so 400 plus 200 gives us $600 is how much he will have earned by day 5. And that stands to reason because we're going to continue to do this pattern out as far as we possibly can. Juan's friend Eduardo has also earned $200, but he continues to spend each day at a rate of $25 per day. Compare and describe the meaning of the slope for each person. Okay, so in the case of Juan here is, and we're describing his slope was $80 a day. So Juan earns $80 a day. And that's describing the meaning of his slope, because his slope is 80. Eduardo will be earning or earns $25 a day. So his equation would be y equals 25x, but he's starting at 200 also. So which one has the steeper slope? And you can say who's earning a greater rate of change. And of course, we know that Juan is in this situation. I hope this has kind of helped you guys understand slope and how to create your equations of the line based on slope and y-intercept. And this should be a fun lesson for you. I hope you enjoy it.